When you're web scraping and you see a screen like this, it often has the exact same energy as screens like this. It kind of feels like you're stuck. There's no moving forward because the web scraping automation is blocked by Captcha. We want to solve that in this series so that we can actually get the result that we're after, which is really just web scraping our various products. Whether it's the price, whether it's the ratings, whether it's the product details, whatever it is, this is public information that we want to grab and make sense of over time. That's really a key part of this as well. Now you might think that this problem is solved by using a tool like Selenium. If you're not familiar with Selenium, it is a programmable web browser that we can use to do all sorts of things that a web browser can. So for example, we can actually go to a web page of some kind, we can wait for it to load, especially if it's JavaScript heavy. We wait for it to load, and then we can start doing various things a normal human would do, but it's all done through code. Now, this is different than web scraping with just a regular program because it's actually through a web browser itself. This also means we can take screenshots of that page if we wanted to. Now, that's not something we're going to cover, but the idea is thinking that Selenium would solve this problem is definitely valid, but unfortunately, Selenium will just highlight this problem. It'll show us that this is a problem. So, of course, that is not something we want to have happen. We still need to solve that Captcha problem. And to do that, we partnered up with Bright Data. Bright Data will automatically integrate with our Selenium to actually solve that Captcha problem. It will also give us an IP address so ours isn't being tracked or maybe blocked, but it will also allow us to execute our code on their servers, which will be somewhere else in the world. It won't be on our local machine, which gives us a better look at what this web page is look like regardless of where we're located, which is actually pretty interesting to see if the price data changes depending on where we are in the world. I would guess that it does, but there's a really good chance that we want to be able to scrape this itself. So that's the goal of this series, to be able to web scrape on a regular basis reliably and also solve those Captcha data items using the tool of Selenium. Here are the tools we'll be using in this series. First and foremost, we'll be using Selenium with Python. So of course you should have some Python experience. Then we'll also be using Beautiful Soup to parse that data. We're going to have these things happen at the same time through a Jupyter notebook. This will give us an interactive environment so we can rapidly iterate on what we're trying to do with Beautiful Soup and Selenium. Jupyter is not required to do this, but it is incredibly interactive, so we can build out exactly what we want, then to integrate it into our Django project. Now, the reason we're using Django is for the models, for the ORM. So we can actually take that parse data from Beautiful Soup and Selenium, and then we can actually store it into a database so we can track it over time. That's really the key, is being able to track it over time. And the way we're going to track it over time is by integrating Django with Celery. Celery is a background process that allows you to run different Python functions on a schedule or asynchronously to when you call it. And this happens because of something called Redis. Redis is the data store that's integrated with Celery, where Django can have all kinds of SQL backends and even a NoSQL backend. Django itself doesn't necessarily need Celery to run. Celery also does not need Django to run. But when they come together, you can use the Django admin to manage your Celery processes, but you can also use Django to just call various functions you want to run asynchronously through Celery. In our case, we're going to be doing our actual web scraping through a Celery process so we can run it whenever we want to, or we can run it on a schedule itself. So it can happen every 5 minutes, every minute. You can have it happen every month, every other month. It really is up to you when it comes to that. And it's actually very straightforward, as we'll see. Now, all of the code is available on my GitHub. This will be linked in the description. In here, there's also a few references that you might want to go through to actually start and learn this particular material or set up Redis itself. Now, I do recommend that you go through the code. If anything's confusing at all, definitely check the notebooks once they are available there. Now, if you're not familiar with Django, we're really just scratching the surface of Django itself because we're really focusing on Django models and the Django admin. These things are very, very straightforward. When it starts to get complicated, so when we build in the web part of it, whether it's views or templates, I think the Django models, at least on the fundamental level, are fairly straightforward because it's basically just a Python class. Now, you don't have to use Django, but Django integrates well with Celery better than I think most. So that's why I use Django, and also for the admin. If you aren't familiar with Django and you want to learn more prior to jumping in, your first Django project, this course that I have on my website, is a great place to start. Or, of course, you could always do Try Django on YouTube. This is Try Django 3.2, but of course, at some point, I'll have newer versions of Try Django. That being said, Try Django itself, the version doesn't matter so much because Django itself is pretty mature and it's been roughly the same since about 2015 or so. Then, of course, we're going to be using Bright Data as our proxy service. So be sure to sign up for Bright Data right now at this link here. Of course, I partnered with them on this one, but the general idea is we're going to be using their proxy service to make sure that our requests work really well and work reliably with the desired outcome that we have. Now, there are a few other smaller tools I will use when we need them, but for now, that's it. Let's go ahead and actually start our project. We're going to do a rapid fire Celery, Redis, and Django integration so you can see how it all works before we use the reference code. Now, this is in direct reference to the blog post that you see right here. This blog post is fairly straightforward. It goes step by step. It might give you more detail than we cover in this video, but let's go ahead and get this started. First and foremost, I'm going to be using VS Code for this. I already have a virtual environment installed here. I recommend you do the same. Then I'm going to go ahead and create requirements.txt. These requirements are related to making sure that Django and Celery work well together. Here's a few of them. Python decouple will just load in my environment variables. So let's go ahead and run our Python module pip install and requirements.txt. Feel free to upgrade pip as you see fit. But after you do that, I'm going to go ahead and create an SRC folder. This is where both our Django and Celery applications are going to live. First off, we start our Django application. So let's go ahead and navigate into that folder with Django-admin and then start project. And I'll call this CFE home with a period at the end. Now, I'll name all of my projects CFE home so I know exactly where the settings file is. Feel free to name it how you see fit. Now, once I do that, I go into this SRC here, and there's my CFE home. Now, CFE home in this case will also be critical for Celery and how we actually call Celery itself. Now, before I actually implement Celery, I want to have Redis working. So in my local machine, I have the Redis command line tool installed, so I can run something like Redis CLI ping, and I'll get this connection refused. This is because, of course, Redis is actually not installed at this time. Now, I'm not going to cover installing Redis, but there are many different ways on how you can do it. In my case, I'm going to go ahead and use Docker Compose. So inside of the root of my project here, I'll go ahead and do compose.yaml. I'll go ahead and bring this in, this already existing Redis Compose file, basically using the Redis server. It's very, very straightforward if you know Docker Compose. Once I do that, I'm now going to go ahead and run Docker Compose up. I'm not going to put it in detach mode because I actually want to take this down when I'm done with my project. I'll go ahead and open up another terminal window, hopefully with my virtual environment still activated. Even if it's not, I'll go ahead and just verify Redis CLI ping, and now I get Pong back. So I actually have connection to Redis at this particular location. So since that's my location, I'm now going to go into my SRC and make .env. I want a .env file here because I want to declare the first level of my environment variables, which is going to be my Celery broker Redis URL. I name it this way because I might use Redis in other ways, like just the Redis URL itself. So then I'm going to go ahead and declare the Redis connection to my local host at 6379. 6379 is the port that's default to Redis, which is what I'm also using in Celery itself. So, or rather in Docker Compose itself. So if I wanted to change it to a different port, I would need to change those two values right there. I'll leave the default one for now. So in these environment variables, then I want to go into my settings and I want to be able to load these things in. This is where Python decouple comes in. So we run from decouple import config. So then at the very bottom of this settings file, I can bring in that broker URL with a default fallback value if for some reason the env file is not working. And so that's now going to be my Celery broker URL. This is absolutely what it needs to be called for in order to configure for Celery itself. There's a few other configurations I'll bring in here that I'll discuss briefly. The first one is storing the results of Celery into the Django database. That's great. The next one is just a warning. This is something for future versions of Celery. And then the final one is the database scheduler. This means that in the Django admin, I can actually schedule various tasks to run, as we'll see here very soon. Now, I use Python decouple instead of OS environment or OS environment.config for the reason that I can have defaults and several other things, but it makes it a little bit easier. But feel free to switch it out to OS environment if you want to go that route. Okay, so the next thing I want to do is in my installed apps here, I'm going to go ahead and make sure that my Django admin actually has access to the results and the scheduler, which are these two packages right here. Now, these packages aren't always going to be cutting edge Django, as in at one point Django 4 was out or Django 4.2 was out, and these packages only allowed for Django 4.0. So just keep that in mind. I'm using Django 5 right now. It works fine, but there's a chance that it might not work on newer versions of Django. Just keep that in mind when you update your projects themselves. Okay, great. So the next thing I need to do is actually configure the Celery application itself. So the way we configure this is through their recommended method, which is creating celery.py in the settings configuration file for your Django project. In other words, next to settings.py, this is where you actually start configuring out all of your Celery information. And I'm just going to go ahead and copy and paste directly from the actual documentation for Celery with Django itself. So what we see here is my cfehome.settings module, the Django settings module. This is the critical piece that you want to keep track of, as well as the name of the application itself is going to match all of those things. Now, whenever in doubt, just go to the WSGI and see what the name is there. You could quite literally copy this into Celery.py itself. This just makes sure that we can integrate with our Django project altogether, and it will discover all of the tasks that are coming for it. So now that we've got that, let's go ahead and try and run Celery this time. So notice I don't have Django running. All I have is my Celery or my Redis URL running through Docker. Now I'll go ahead and run my Celery project, which is simply Celery-A. We're going to declare the app, which is in CFE Home. And to ensure that Celery is finding the correct application, we go into our CFE Home module here into init. Then we do from.celery. We import app as Celery app. And then we just declare it in here as all. And then just Celery app, just like that. Okay, great. So that gives us the ability to make sure that this is going to work every time, essentially, or at least very reliably. So the CFE Home right here is only referred to the module itself, the Python module itself. It doesn't have nearly as much to do with the CFE Home.settings or CFE Home. Those things you could augment or change or move the location of. I just don't recommend you do it in a Django project. So one other thing that we want to do with our worker process is I want to see what's happening. So if I hit Control-C, the worker will start to shut down. Then I actually pass in L as in a log and then do info. So the reason I do this is so I can see more things about what's going on with Celery. In this case, I have 0 tasks actually working. So we're going to go ahead and create our first task. Celery is not needed right now, so I'll go ahead and close it out again. Let it shut down, and then I'll go ahead and do Python manage.py start app, and I'll just call this movies to fit with what we're going to do soon. It has nothing to do with the app name itself, but rather just the example. So now that I've got this app, I want to go into settings.py and just bring in movies, or whatever app name I decided to put there. Now the reason that we have to do this is because Celery itself is going to auto-discover tasks. That means that it's going to look in any given installed app for a file called tasks. So task.py is how Celery will end up finding all of the Celery functions you want to run. So in our case, we'll go ahead and do from Celery. We're going to import the shared task decorator. And I'm going to define a decorator function with, or a decorated function with the add, for example, and I'll do 1 and, or let's do X and Y. And then we'll just return x plus y. That's it. So that's the function I'm going to use. Now what I'm going to do is I'm going to go into my Python shell, and I'm going to call this function. So the standard way of doing it, the non-Celery way of doing it, is do from movies.tasks, we import add, and then we just do add like that, right? So we add those arguments in just like that. If I want to turn it into a Celery managed function, I do add.delay, and then 1 and 2, and then that creates an asynchronous result. Now I want to point out, Celery is not currently running, but Redis is. So that task was now added into Redis. So this is now registered in Redis for Celery to execute. So it happens asynchronously. Now, there are other ways to actually run an asynchronous. There's something called apply async, where we can add a countdown timer. We can do a bunch of other things to it. This is a little bit more advanced and something I'm not going to cover, but it is well documented in the actual code itself. Now, it's important to note as a Django developer, whatever arguments you're putting in here need to be JSON ready. If they're not JSON ready, this will likely fail. In other words, do not use Django models as args. That's it. The instances themselves. You can import the model. You can do all sorts of things that you might want to do inside of the function itself, but you do not want to use the model itself as an argument. Model instances especially. Just JSON data. Great. So with this in mind, let's go ahead and make sure that this result is actually happening. So I'll go ahead and open up another terminal window and navigate into SRC. Once again, we'll go ahead and run Celery-A, and it's capital A, CFE home, worker, beat, and then -L, info, hit enter. And with the info, we'll be able to see the result come out, and it happens as soon as Celery starts working once again. So back into my shell, if I were to call that delay function a few more times, of course, Celery is actually going to run that code a few more times. This is the part of separating what would happen in a normal Django project into a Celery worker itself. Now, of course, we can make this even a little bit more advanced, and we could use stuff like, actually set up a scheduler in here to run these various things. As in, we could run this function on a regular basis inside of Celery.py. That would mean our Celery.py would look a little bit different. We would have this cron tag in here, and then we can schedule out all of these different functions we might want to run on a regular basis. Now, in the case of the different tasks themselves, notice that I named some of them, and then I also added the movies.task.add. This also comes from an updated task.py that now has more tasks in it because there's more advanced things that you can do with it. But I really just wanted to show you that basic example on how you could actually integrate Django with Celery and some sort of beat schedule. This right here could all be done inside of the Django admin, which is the recommended way I recommend you do it with things that you intend to change fairly often, right? So if you plan on sending out emails to specific actions or something like that, that should be done in the Django admin, I think. So then you can change it as you see fit, especially with these arguments and various things that you might want to change as well. So that is integrating Django with Celery and Redis. This is meant to be rapid fire. Of course, the documentation on Celery has a lot more things that you could do with it, but generally speaking, this is it. Next up, if you were to use Django in here, I would import from Django.apps. I'm going to import apps, and then I would do, my model being apps.get model, and then, some app, and then the model itself. That is how I would actually import those models, so then you can get the instance in there as well for shared tasks that require things related to the instance itself. If you skipped the rapid-fire Django, Celery, and Redis integration, be sure to go to this repo right here, jump over into the Start branch, navigate down into Getting Started, and go through that process. If you did do that entire thing, what you're going to want to do is add a few new environment variables in here and change the Redis port. I always change the Redis port. I barely ever use the default port on my local environment, and I always want to set up my project to be going towards production as much as possible. So all of these environment variables are configured in settings.py as well. And then of course, Docker Compose itself is how we're going to run our Redis instance in this case. If you are using another version of Redis, feel free to not change the port. I just do that when I'm using Docker Compose almost always. So the next thing is I want to make sure that I can run my various commands, one being Docker Compose up. I like having this one running not in the background on my local machine just to make sure I'm not conflicting with other ports. If you do conflict with another port, just go ahead and change it. And of course, if you have questions on Docker Compose, let me know in the comments. But of course, the commands that we also want to run are these right here. These are the main commands we'll use when it relates to using Django and Celery. When we get into the Jupyter notebooks, we'll just run Jupyter Notebook as well. So those are probably going to be the main commands that we'll have throughout this one. But the idea being is we want to make sure that our actual server, our Celery worker, works. So running it like this, I get this invalid app thing here. This, of course, is because I'm not in the SRC folder itself. The module CFE home was not found because it's inside of SRC. So let's go ahead and cd into SRC, run that command, and I should see something like this. And I should actually see tasks actually already coming through. If you don't see this, then there's a number of things that are incorrectly configured. One of those things, probably the main one, is the fact that you don't have access to Redis. So it's really important that we do have that so we can do everything going forward. So at this point, we are now ready to start bringing in the Jupyter notebooks so we can actually do the web scraping process. Now let's take a look at how we can use Selenium to do some web scraping. And of course, we'll do it in Jupyter for the interactiveness of it all. Make sure you install those requirements into your local project and then run Jupyter and Notebook. Now, for some reason, when I run Jupyter Notebook on localhost, it's not working for me. But if I change it to 127001, it does end up working. So not sure why that's happening, but it did happen. That didn't used to happen. Now I'm going to go ahead and create a new folder inside of my project here. And I'm just going to call it MBS, as in notebooks. This is where we're going to go ahead and do our Hello World notebook. And it's very simple. So we'll go ahead and do Hello World with Selenium. Okay. And so what we should see here is an issue, a challenge actually come up. So what I'm going to do is import the two main parts of using Selenium. That is our WebDriver and the Chrome options. So what I want to do first is declare the options I'm going to use, which is just simply Chrome options. Now, every once in a while, you might want to use the headless argument. So add argument and then -- headless. And we'll see what this looks like in a moment. Next, after we've got that, let's go ahead and grab a URL. In our case, I'm going to be using Amazon.com and specifically the PS5, the PlayStation 5, just to scrape that, or at least that's the goal in the long run. And of course, I want to make it so that I can use any product here, not just the PS5. But of course, this might change depending on where you are in the world and how the actual web page is designed at this time. But as it stands right now, I think this will be pretty good for some time. So now that we've got our options and our URL, let's go ahead and use the WebDriver. So we'll go ahead and say with WebDriver dot Chrome and options equaling to options. Now, for those of you who are unaware, Chrome, as in just like our Chrome web browser, this is going to be running as a completely separate instance of our current Chrome web browser, but there's options for Firefox and a few others as well. As a potential browser that you could use. But I'm going to stick with Chrome. I find it to be pretty reliable overall. And this is using Chromium. So now that we've got this, we declare it as driver. And then we can do driver.get URL. And this is an HTTP GET request. So this is very similar to like if you were using Python requests and you did request.get of that URL. Except, of course, this is using an actual web driver, which is from Chrome and Selenium. So if I go ahead and run this cell now, what's going to happen is, since I'm not using headless mode, it quite literally opens up that web page for me. Now this also times out, so it actually goes away from it. So let's go ahead and import time here. And I'll just go ahead and do time.sleep, and we'll do 10 seconds. Okay, so I'll run it again. We didn't have time to find. Let's try that again. Run it again, and now what I can see is there's that Captcha. That's the dreaded Captcha that we see now in action. And so, of course, we want to avoid this, but we see that Chrome is being controlled by automated test software. So the actual Selenium itself is really useful for testing out web applications as well. It's not just made for doing something like this where we're web scraping, but it can be done that way, and that's absolutely what we want to do. So with this in mind, we now want to actually adopt using our Bright Data proxy so that this portion right here actually works. It works well. Now we're going to go ahead and implement the scraping browser API. So be sure to sign up on Bright Data right now so that we can have the proxy service to actually do our request for us. But before we do, I want to take a look at something, and that is this page right here. Right? So in my local Chrome browser, I want to view the page source in here. Now the reason for this is so I can just kind of get a sense as to what's going on with this page. Now this is not at all what the page is that's coming out as far as the data is concerned. Now what this is showing me is that this Captcha that's happening is also actually blocking the content itself. So the content is not showing up. Let's contrast that with a page that's not currently being blocked locally. If I inspect the elements here, I can see that it's quite a bit different, or I could obviously view the source code here. It's quite a bit different and it's quite a bit longer, as you can see right there. So that's the key here, is that we want to make sure that when we are scraping, we're getting the correct one. And so what would happen with our Hello World with Selenium locally is it would give us false confidence because we can still get the HTML. So I can run this and go ahead and print that out. Now, naturally, with it being in headful mode, then I can actually see the result of the scraping itself. I see the web page and I can see that problem. But of course, the problem is almost unseen completely if I just add in this headless option here, or headless being new, and run that now. This time it's not going to actually open up Chrome anymore. It's just going to eventually print out the HTML content itself from that request. So this is where it's sort of hiding in plain sight that the HTML content does not actually have valid content. So if I were to try to parse this data, I may or may not actually get the correct data coming back. Right? It's difficult to say. And so I don't want that to be an issue. I don't want that to be a part of this process. Instead, what I want to do is I want to be able to actually get the correct data all the time. And so to do this, we're going to go ahead and jump into our Bright Data account, and we're going to create a scraping browser proxy. So if you see something like this, just go through the getting started process. Eventually, what you'll land on is this right here, or something very similar to it, where you've got a host for default and Selenium. You've got a username and password. Now, I have this on video, so of course I want to change this and have a new password at some point. I'm not going to do that just yet. So the idea then is once we have these credentials, we can start using it. And what we're going to do is we're going to jump into their integration examples. So we'll go ahead and open that up. And we want to navigate to the language being, of course, Python. And then the library. Notice we've got other options here, but I'm going to be using Selenium still. And I'll go ahead and copy this data here. And I'm going to bring it into a new notebook with that same URL, and I'll paste it in. So, of course, I can create it as a function similar to this. I will go ahead and do that, but this one is just going to be called scrape. And what I want it to do is send back HTML data. So first off, I'll set an empty string of the HTML, then I'll return back that HTML like that. And we are really just trying to build this towards being really reusable itself. So the URL itself is going to be URL and URL being none. And then we'll go ahead and use this URL in our different stages of this request. So I'll go ahead and put it into the navigation to, and then also the get argument in here. And so what should happen is we should be able to get the actual data that's coming through for that page. The other thing is we notice that there's this solve a Captcha command. There's a way to solve Captcha, which is really fascinating. But we might not need to do that. We will find that out when we go to parse this data. But for now, what I want to do is just use this itself. So let's go ahead and run these two cells and pass in the URL like this. And so what we should see is our actual HTML coming back once it's all said and done. And it will take a moment to actually run the scraping process. Now, a couple things to note here. The first one is this Chromium remote connection. Notice that it's Chromium. that is the same thing that we were using here. It's the same type of browser. So in many ways, it's a drop-in replacement for that, except it's a remote connection. So that's going to happen, of course, on the proxy server. And so we need to make sure that we get that remote connection based off of our bright data here, our bright data connection string. And then we actually can pass in all of the same Chrome options or other options if we need it. There are options that you might use, something like a user agent at some point. But in our case, we're just going to leave it just like that. And then we get some data back. Now, this is a lot of data, right? So I have a really good feeling that this is done correctly. Correctly as in Captcha didn't stop this data. And we could probably search through it to see if PlayStation's mentioned several times or really whatever product we ended up using. But I'm going to leave that for when we start trying to parse this data out. Now, I will say parsing the data after we scrape it is not always something I recommend that you do. A lot of times I would say, hey, just store this raw HTML data locally somewhere and then parse it later. That later could be in 5 minutes. It could be in 10 years. But the idea being the parsing of the data and the scraping of the data are two separate activities normally. And so you should start thinking of them as such. Because we can scrape this web page over and over and over again and then use parsers to find what's different. Those parsers are getting significantly more sophisticated because of AI and LLMs. Now, the AI and LLM stuff is outside the scope of this, but the idea being that we scrape more data than we might need, and then we can save that more data than what would be necessary. Now, of course, we could always narrow it down in here. You can use Selenium to narrow down the data that's coming back to you. And that actually might be a good thing in the long run based off of the proxy service and how it's going to be sending that data back and forth. But to me, I would rather have more data than less. So with this in mind, I now want to actually take this data and turn it into actionable data by using Beautiful Soup. But before I do that, I actually want to turn this also into a more reusable function itself so that I'm not always calling it like this with the API keys and stuff like that all exposed. So before I actually move to the next one, I want to delete this password from my account. So I'll go ahead and create a new one, and I'm going to delete this old one. The reason for that is so that this notebook, it doesn't really matter if that's exposed because I'm not really using it any longer. Now we're going to go ahead and bring this scrape function into its own module on our Django project. So I'll go ahead and copy all of this code right here. And then inside of SRC, we're going to go ahead and create helpers/init.py to generate the module. And then I'll go ahead and do brightdata.py and paste this in here. Now, one of the key things is we need to make sure that this is an environment variable instead of a hard-coded variable. So to do that, we're going to go ahead and bring in Python decouple, and we'll import config. And so naturally, the configuration is going to be very similar to the variable name itself, and we'll just give a default of none. And so to bring this variable name in, I'll go ahead and cut out this code here, and we're going to go into .env, and we're going to bring this in. Now, before I actually declare all of the variables related to this, I want to make a note that inside of sample.env, we can see that the format of it is our user, password at the host and the port. So in the long run, you probably want to separate these things out because maybe you rotate your password a lot and you want to make sure that those things are rotated, or you rotate your username enough to where you want that to be separate out. I'll let you do that on your own, but basically having 3 or 4 variables here instead of 1, that's kind of the idea. And so with the 1 variable, I'll go ahead and just leave it in as is with the equal sign like that. Now, I actually deleted this password, so I want to make sure that I change it as well. So back into Bright Data, I'm going to go ahead and copy this password now. There we go. And so now I just want to check that this is working. Now, the way I have to check this is working is directly in the SRC folder itself based off of how a number of these things are configured. So to do this, I'll go ahead and make sure that I'm inside of that SRC folder, and I'm going to run Python, just Python, and we'll go ahead and do import helpers. I should be able to see that helpers does get imported, and if I do helpers dot brightdata.scrape, then I'll be able to run it. In fact, I want to do one more thing with my helpers first, and that is in my init method, I want to do from .brightdata import scrape, and then we'll go ahead and do our all call here. And this is going to be equal to that scrape function. And let's go back into Python. The reason for this is so that I can import helpers and then just call helpers.scrape and then pass in the URL we might want to scrape. In our case, that URL is going to be this one right here. And we'll just go ahead and bring that in as a function. So helpers.scrape and URL equals to just like that. And of course, there it's going. It's going to connect. It's connected. Everything worked. And then it'll probably print out all of that HTML. So you might be tempted to say, oh, let me just load this into Jupyter now and have that work. But unfortunately, the way I have Jupyter currently set up is it's not going to work natively like that. So we actually need to make sure that Jupyter and Django are connected before something like this can just work. In other words, I can't go into a notebook right now and try to import those helpers. So let's go ahead and try that. So if I do import helpers, it's going to attempt to do that. But the reason for that is because of where it's located and how these things are working, right? It's inside of the MBS folder. That's where this current notebook is running, which means that it's inside of this folder right here, and it can't just find this helpers module from that. And it also can't find the Django project either. So we're going to go ahead and configure it so it works with both the Django project and the helpers. Then we'll start parsing out the data. Now, as you may know, Python manage.py shell allows you to use Django inside of the Python shell. We want to do something similar inside of Jupyter. We want to be able to use our Django project in any Jupyter notebook that we see fit. And for that reason, we need to actually create a module for this. Now, there are third-party packages that help do this same thing, but I've always found them to be, well, not always as reliable. So what we have here is setup.py. What this is going to do is give us a function that will allow us to call our Django setup. Now, this is all in the repo or at this link right here, but the idea being we declare what our Django project is. Notice there is the environment variable for it, not the Python decouple. That's on purpose because this right here should run regardless of Python decouple or anything else, but basically from environment variables, and we can always call things as well. But the idea being that we want to grab the root directory where our Django project is. In this case, it's in src. So that means that the Jupyter Notebook's root will be basically src. So let's see this in action right now by actually taking a look at our Jupyter Notebooks again. And so I want to go ahead and open up the Jupyter Notebook server again. And I'm going to go ahead and jump into one of the ones we've been working on first. So in this one right here, I'm going to go ahead and make a new cell here and do our pwd command. And we see that it says NBS. Okay, so I want it to say src. I want it to be in the root of the Django project. So to do this, I'm going to go ahead and duplicate this one. And we'll do save notebook as, and I'll say 3, and we'll do helper-based proxy scraping with Selenium. And this one is really just going to be so we can import helpers. That's the goal here, so that I don't have to run all of this, but I can just run the scrape call itself. So once again, I'm going to go ahead and add in another cell here. This time I'm going to go ahead and import setup. So this one does actually get imported. This one actually works simply because of the fact that setup.py is inside of MBS. If setup.py was not inside of MBS, it would not work. Next, we're going to go ahead and call setup.initDjango. And I'll go ahead and do my project name being CFE home. Granted, I have that in the code already, but I want to make sure it's in there so that when I do go to set this up, it does work correctly. Now inside of here, I'll go ahead and do pwd. Notice it's in src. So literally every time I run that, it's going to be in src, which means that I can call helpers, which means that I can call helpers.scrape. And then that is how we can go through this going forward. What I'll also be able to do is like from Django, or rather from like our, let's say our products.models, we'll be able to import a product itself. Something along those lines will happen as well, thanks to this simple configuration. Now we're going to use Beautiful Soup to parse out the HTML that we scraped. This parsing process often gets conflated with the scraping, but it is different. Parsing out data is quite a bit different than scraping the data and just getting the data. The thing is, every once in a while, you might need to scrape data, parse a piece of it, and then scrape more data based off of that parsing. In this case, we don't need to do that. We just need to scrape the data and then parse it for what's inside of that data. And so one of the things that Beautiful Soup does really well is it turns HTML into searchable text with Python. So let's take a look at what HTML is first. Every web page ever has HTML. That's the defining characteristic of the web and the internet. So you can always see the page source of all of these different web pages. Now, to actually parse this data, it's not always that straightforward. Sometimes it's a bit of an art, sometimes it's a bit of a science. So what we want to do is we want to see some of the things that are fairly basic, and then I'll give you some of the answers to make sure that all of this is working correctly. So the strategy I always take is I go to the elements I want to use inside of Chrome, and then I use the inspect item here. So I click on inspect. That allows me to select the actual HTML element that's inside of the HTML. And I can actually navigate around it to see what else is being highlighted. Now this makes it a little bit easier when I put the doc on the actual right side. I can see it quite a bit more now as to what I'm selecting in the code itself. So when I go back to inspect it, it actually brings me to the HTML element, quite literally the HTML element that I need to extract. So I'm going to go ahead and copy this one by going into Edit HTML. I'll just copy that one single line. Then I'll go into my Jupyter notebook and I'll initialize all of these things as I need to. So the first thing is I'm going to bring this markdown in and I'm going to go ahead and say HTML is equal to this. Now notice I already installed and imported Beautiful Soup, and then I turned my HTML into a Beautiful Soup instance, as we'll see in a moment. But of course, when I actually render out any given element inside of using Markdown, I can actually see what HTML is coming through, which is really nice. I've got a span here, that's the name of the HTML tag, and then I've got attributes on that tag, ID and class. These are very, very common attributes. Inside of this tag is actual text. This is what is often rendered to end users. In this case, it's very clearly rendered to end users. Now, that's not the only element that contains this data. So if we actually went back in here and scrolled up a little bit, we see that there's a div tag in here too that also contains that data. So both of these things are actually valid. If I were to paste this one in now and separate this out a little bit by pressing enter after each tag, I can see what's going on with this div itself. Okay, so this part right here is contained inside of this div, which is also contained inside of this h1 tag. Now, this is where the art and science come up a little bit. On one hand, you have this div that does contain this text, but it's really high level up, and it could contain other text. But in this case, it actually contains the right one. So there's also these IDs in here. So as we get narrower and narrower to the text that we want to grab, we can see that there is a span of ID being just like this. Now, to actually grab that element, what we could do is just quite literally say product title equals to soup.find the span itself. Okay, the span itself, what do you know? And then ID equals to, what do you know? There's an ID right there that I can actually grab and use as well. And then I can take a look at what comes back from that search. It's quite literally the same exact thing. And if I do .text, I get the actual text that's in there. And so if I wanted to say the product title text, I could set it equal to that. And then I can do .strip to use built-in Python to actually strip out the text. So it's quite literally the exact text that I want. And so every once in a while, you might want to put this into an F string as well, just to make sure that you know that this method right here is a Python method where the .text is an actual soup method or a Beautiful Soup method. And so that's how we can get the product text itself. That's fairly straightforward. How about something else? Something maybe a little bit more important, as in the price. So if I inspect the element here, the price itself, well, it does have a span in here, but it does not have anything related to an ID. So let's go ahead and grab the span that comes through, and then I'll come back in here. And once again, I'll do my markdown here, and I'll use those ticks, HTML. There we go. This is just to give me a reference that I don't have to flip back and forth on all the time. Once again, I can do the span. So I'll go ahead and call this product price now, and just change this to these like that. So find the span, no big deal. That's going to do that. Instead of ID, we want to do class equals to, and then a price whole. Now, when it ever comes to classes inside of HTML, there's typically lots of classes with that exact same name or that exact same class. IDs, on the other hand, are usually unique. You're usually just one ID for that. So what happens then is we need to change this to being find_all so we can actually see all of the instances of this. If I run it now, I've got a lot of them. Luckily for us, most of them are, well, the top few are the correct ones, or at least I think they're the correct ones based off of what we've got in here. So we want to grab just the correct one itself. And that's going to be, we're going to just make the assertion or the assumption that it's the very first one. And that will give us this element here. So then I can do something like this where I'm actually getting that value. Now, one other aspect of this is maybe I want to only have the digits. So what I would do then is say x for x in that data if x.isDigit. And now I see that the digits are there, but then I can just rejoin them. And now I have my digits and I've got my product price text. And if I wanted to change this to product price number, then I can go ahead and do that with my actual number itself, which would be the int of that product price text. And we would see something like that. Great. So that's an actual number that I can then multiply with and do all that. Now, there is one problem with this, though, is that is if there is a period in here, we want to keep that. So I actually want to say or x equals to a period, because if I do have decimal places, I want to make sure that I have those. And so now I get this invalid int for that right there. And so this integer itself won't actually work. We would need to use a decimal. And of course, this could be solved by just saying float instead of int. And that will give me a somewhat accurate look of as the price itself. And of course, if I actually multiplied it by something, I might get something like that. We could also import from decimal, import decimal to get a even more precise price here and just run based off of that. But of course, that doesn't allow me to multiply floats and stuff like that. So maybe you don't do that method. But overall, what we see is we're going to see the price come through and the product name. Now, this might be enough. This might be all you actually want. But perhaps we can go a little bit further. And so that's what I want to do. I'm just going to go ahead and copy and paste a few things that I found, such as the product data. And this is going to be quite literally the product data. If I do .text, I can see that this is all the product data or the product information that was listed out for us inside of, let's scroll down a little bit, and here, right? So that's literally all of that product data, which we can, again, inspect the element here and find out where those product details are. That's how I found it. It's right there. Cool. So I can actually turn this into something a little bit more usable by not actually having the text, but rather having the table that's in there. So something that Soup does really well is once you do find an element, you can do another search inside of that element with .find. So that's, of course, before you do .text, but then you can find a table, for example, and get the column names from that table. That's a simple example of how you could do that. Once you have that column names, you could then get the table data itself. Once again, we see that our table's in here. We're going to enumerate all of the rows, which are typically in TR. Then we find all of the cells. And the way this table actually works is a little bit different than some HTML tables. So what we do then is we just run this, and then we can get out our table data. And that gives us a bunch of data about that specific element. I definitely glossed over how quickly I solved this problem, but it is something you can do fairly straightforward by iterating through tables and finding out what that data is. Now, another thing that I wanted to look for was the Amazon shipping number, or the Amazon ID number, the actual unique one. And one of the ways I did that was by doing elements with the attribute of this particular attribute. So this is actually really cool because sometimes you might not know what the HTML element is, but rather you see an attribute that you're looking for. In this case, it was this attribute. I happen to find this one to find out what the Amazon shipping number is, or the ID number. And of course, those actually correlate together. This and this are the same thing. So I actually feel pretty good about where that one is in terms of the data. Next up is the actual product description. I found this one as well. It's in the div tag with an ID of product description. That one's super simple, super straightforward. And then every once in a while, you might want to find something like the feature bullets as well. And then the final one that I actually do want is the rating itself. So the rating data I also found from ID average customer reviews. And then inside of that one, we had a bunch of base data in there as well, which we can see with that right there. Pretty great. And so once again, we might want to actually run through that same sort of stripping where we look for whether it's a digit or not for the average rating itself. And we just do that with this right here. We don't need to strip out the text or anything like that anymore. But now I can see that this average rating is going to be the same value. But I'm going to then go ahead and just say float of that value. And then I can actually see what that average rating is. What's cool about this too is I can also then use that same concept and get the average rating count. Once again, I found this ID on there, and I'm not even putting the HTML attributes anymore. I'm just getting the IDs, and there you go. So this time it's going to be an actual integer itself. And so, well, I mean, it's very unlikely that the actual number of customer reviews is going to have a decimal place itself. So we can consider this an integer as well. So yeah. That's pretty cool. So that's actually parsing out the data. I realize I went kind of fast with a number of these things, but that's where you're going to want to play around with it on your own to just navigate and use inspect, find what's in there, and just really play around with Beautiful Soup. There's a lot more to it than you can do than just this, but I just wanted to extract the main data that I wanted so that I can then easily change the product, right? So now what I should be able to do is if I go into like Xbox, right? And I grab an Xbox link. Let's go ahead and grab this one. So in theory, what's going to happen is it's going to grab all of that same data all over again. So I'll go ahead and go right above this. And I'll do this URL now as our main URL. And we'll go ahead and run everything once again. And if it was designed correctly and the Amazon web page didn't change, as in these items didn't change, then what we will end up seeing is quite literally that same exact data coming through, which I'll let it finish scraping. And here we go. So we've got our Xbox bundle pack. There's the price. There's all of the columns. There's all of the data itself, the actual ID. Yeah, everything looks great. 4.5, only 48 ratings. So this is probably not the best actual one, but we see 48 ratings, 4.5. We see the price. We see the name, right? So there's a lot of different things that we can learn just about that itself. But now we're at the point where we should be able to start scraping this on a regular basis. But first what I need to do is actually turn this into a function that extracts all of this different data so that it's a lot easier. In other words, I need to turn it into a helper, much like we did with the scraping portion. In between that last notebook and this one, I was running into Captcha issues of all things. Now, what I tried was the logical thing that you would try, which would be to jump into your helper function for scraping and then just implement the solve Captcha method. Now, Amazon's Captcha is different than this solve Captcha method. Amazon has their own proprietary Captcha that, well, brings up this page right here. So what you actually need to do is you need to actually reach out to Bright Data themselves and ask for residential network access. You're basically looking for a residential IP address to be used when you do your scraping, and it's going to be specific for your account. It's really easy. You just talk to them, make sure that you are a real person, essentially, and you're able to go through, and then you'll be able to scrape out your data like this. Now, if you are running into issues and the data is not coming back, what you're going to end up wanting to do is you're going to want to output that HTML so that you can actually see it just like I did here. But what I want to do now is actually want to turn in everything that we just did into helper functions so that we can reuse it throughout our project and then also load it into a database model inside of Django itself so we can track changes over time. Now, the idea here is actually very similar to what we've already done, but I'm just going to put it into functions. Now, I actually already did this because it's fairly straightforward, but the idea being that we want to set everything up, grab a URL. I have two different products here just to test it out. I can also navigate to that product or either one by opening it up like that. And then I can also go through and define all of the various functions that I might want to have. So I've got this find, table data. Here's that same table data that we were doing before. Now, if there's a chance that this changes over time, yeah, you might need to adjust the class names and the IDs. I don't actually think that's going to happen. I think these have been pretty much the same for years now. I think because Amazon, to a degree, wants people to scrape on their site so that you can actually buy things from their site, right? So they don't necessarily encourage it, but they also don't actively discourage it from legitimate sources to download different information and then use it. So in this case, that bright data is a legitimate source for that web scraping. And then also what we end up doing with it is also pretty legitimate. In this case, I want to track this price until it goes down to a place where I actually want to purchase it. That's in Amazon's benefit, of course. So the next thing we've got is this find rating. Of course, we've got that function. That's the same thing that's happening here. And then I just basically put all of that into an extract Amazon product data function itself. This again is fairly straightforward. It's just taking everything we just did and putting it into a function. And then I run that web scraping with this in here. Now, one of the things I did change about the scraping process was getting the body element only. What this will do is actually get less bytes that are being sent back to you from, Bright Data's actual servers. Now, in this case, it's going to ignore all of the head tags and also the JavaScript that might be in there if it's in the head tag. But that might also affect how we actually get our data out. In our case, it doesn't affect anything because all of the data we're scraping is from the body itself. But if you were to go in and want to see, let's say, for instance, we go into view the source document here. So view developer, view source. If you wanted to grab some of these elements here, you might do that separately or you get everything else. But the idea here is what I wanted to do is basically get rid of all of this stuff. I don't necessarily need that, and it's just extra data that I can just kind of remove and do away with, which is why I updated it to work the way it does. Great, so now that I've got this, what I want to do is bring it on over into my helpers, and so we're going to call this, I'll just call it Amazon.py, and I'll go ahead and bring in everything related to it. So first off, the helpers, beautiful soup, and then our functions here. So there's our function, and we'll go ahead and grab all of these ones as well. Okay, so now with this, I'm going to go ahead and go into my init, and we're going to go ahead and do from.amazon. We're going to import the extract Amazon product data. We'll bring that in there just like that. Okay, so with this in mind, I'm going to go ahead and do kernel restart and clear output of all cells. And basically from my helpers here, I'll go ahead and do the helpers dot, and this is going to be our extract Amazon product data, which is of course going to be from our HTML. That HTML we still actually need to scrape itself. So we're going to go ahead and bring that back up, and we'll say data equals to that. And now I just want to run those few lines. If this works well, then we'll be able to start the process of bringing this into Django models. So this is really not extracted save data to Django model just yet, but rather just preparing the helper function itself. And looks like it worked. I went ahead and did data and then did it down here as well. And sure enough, there is that data. I also get this warning here based off of I didn't specify the parser that I want to use. And then it tells you, it basically goes with the default one. So that really just comes into whenever we initialize Beautiful Soup itself, we need to pass in that HTML parser. Otherwise, we'll get that warning error. I think it didn't do that in Jupyter Notebooks because it, I guess, assumed that's what it's going to be. I actually don't need the helpers in here. I just need Beautiful Soup itself. And there we go. So we now are ready to start transitioning this data into a Django model. So let's go ahead and do that now. Now we're going to store our scraped data from Amazon into our Django model. Before we do, I want to point out that the Amazon Standard Identification Number, or ASIN, is unique. This is true across all of Amazon, so it's actually really nice to know because it's really just the product identifier that Amazon gives. Now, that is not going to be our primary key, but it will be critical inside of our Django model definition and how we actually enter in data into our own database through Django models. So let's go ahead and do this now. First off, in our actual helpers themselves, we actually updated it so the ASIN would come through in that data. So once that data is coming through, what you'll end up seeing with these scraped data is the ASIN being very, very prominent in there. That is critical. We want to make sure that we are scraping that data. Now, for some reason, it's not coming in with yours in the helper functions that we've got. Just go through the first one when we parsed it. We went through this whole process of getting the asins in there. This is the most critical part next to probably the price. So even the title is going to change, but the price and the asin are the ones that we're really looking for here to make sure that those, well, are consistent when we actually do the saving process. Great. So with this in mind, let's go ahead and now design our model. The first thing that I want to do is, of course, inside of the SRC folder, I'm going to go ahead and do python manage.py, and I'll do start app, and this is just going to be products. I'm calling it products, but you can call it whatever you'd like. The reason I'm calling it products is mostly because we're going to have two primary models. The first one is going to be our product model. Now, I could call this an Amazon product, or I could just call it product. Decide what you want to call this later. After you understand the structure of it, you can always change the name of the models later and then do your scraping process with all that. So the first thing is going to be the product. And again, I said the asin is going to be one of the most important. And then we also might want to have the title in here and maybe the current price, or really the last known price. And then we also want to have a timestamp, as in when was this product added into the database, and then when was it updated. Those are the main ones that we'll want to have. And then we'll also have a metadata, which will really just be the most recent data that was scraped in there. So this same concept realistically is going to be passed on to the product scrape event. The one difference being that the product itself will be a foreign key to the scrape event itself. So you come in something like that. And then you want to do on delete in here, and it's going to be models.cascade. So basically, if the product is deleted, all of the scrape events will be deleted as well, which you may or may not want to have, but we'll leave it in as it deletes it. Next up, we'll go ahead and do our related name, and a related name just being the product itself, and I'll call this scrape events. So basically, once we get the product, we can do object and scrape events.all, that kind of idea. Cool. So now we want to fill out all of these pieces. Now, before I do that, I also want to add in one more thing for the scrape event, and that's going to be our product scrape event manager, and this is going to be models.manager. And so what we want here is create scrape event, and it's going to take in self and the data that we scrape. So first off, we want to say if the data does not have the asin itself, we're just going to go ahead and return none. So we're not saving data that does not have an asin in there because, well, we failed to scrape it correctly. Next up, we'll go ahead and do product and created. And what we can do here is we can do product.objects.update or create. And this will allow us to then pass in that asin. So what I'll do here then is just say asin equals to this right here, or none. And basically if asin is not, or is none, then we'll return none. Okay. So the update or create function, we can pass in the asin in there as the thing that I'm really looking for. So with that in mind, let's go ahead and add in the asin in here, and I'll do models and char field. And the max length I'll use, I'll just say 120. And we'll go ahead and say that it's unique. And I'll also add in it as a DB index. So basically that the database can filter these items better. It'll make an index for these, just like it does with the primary keys. So the idea then is if the asin's not in here, then we're not saving that data. Next up, if the asin is in there, we're going to save that data, but we'll update it every single time. So that's what's happening here. This will update the actual product data itself from that asin. And then what data we want to pass in, well, I'll go ahead and do my defaults. We want to pass in defaults here, and this is going to be equal to the various fields that we're going to update in here. The first one is going to be our title field, and it's going to be data.get and title or an empty string. And then we'll go ahead and do the next one, which will be our price. Well, we'll keep it in as current price and data.get, and this is going to be price or 0. And then our metadata, as in everything else really, or all of the data, we'll just go ahead and pass that in as well. This just simplifies it quite a bit so that if we need to add more data to what we're tracking, we can. Remember, this data has ratings, it has all sorts of stuff, and it'll also have all of this same data. This could be more efficient, but it's not something we're going to do at this time. Okay, great. So what we need to do is bring in the title here, and the character field is probably accurate. I'm going to do 220 here, and then I'll also go ahead and say blank equals to true and null equals to true, because again, the title is not the most important part. Current price is going to be the next one. This one will do models.float field, and we'll do the blank equals to true and null equals to true with a default of 0.00. Okay, and then our timestamp and updated. These are date time objects here, so I'm going to go ahead and do the timestamp and then the updated, and this is just auto now. Great. Metadata is going to be models.json field, and we'll go ahead and say null equals to true and blank equals to true. There we go. So with that in mind, I'll go down into my product scrape event stuff and bring those same things in here, including the ASIN itself, because I also want to have this data in here. Now, one other aspect in here with the scrape event is I'm going to go ahead and say URL equals to none. So basically, every time I scrape it, I also want to get the URL itself, which is going to be models.url field, and we'll go ahead and say blank equals to true, null equals to true. Great. So then in the manager itself, after we create that product, we've got all of the fields in here now. I'll go ahead and say event equals to self.create, and then basically the same stuff, but this time it'll be product equaling to the product, and then the URL is equal to the URL, right? So this URL right there. And what we could think about inside of the model itself, the scrape event, is perhaps we don't want these to be its field, but rather just the data itself, right? So it's really kind of up to us if we want to just have basically the URL and the data, and then having or breaking it down to where the product stuff that's in there as well. I'm going to just keep things as simple as possible and come back in and do something like that to where it is basically the data coming through. I will still get the ASIN in there just to see if I have that one working correctly. And then finally, I'll go ahead and return that event. Okay, so this created, I can just go ahead and do underscore here, and we'll save it. Next up, what I'll do is I'll get rid of these and just say objects equals to this scrape event manager here, just like that. Next, we'll go ahead and bring this into our installed apps. I probably don't need that movies one anymore, but we will leave it in just to save some time. And then I'll go ahead and do our Python manage.py, make migrations, and then Python manage.py migrate. Okay, so to put it to the test, we are going to go ahead and bring in really the scrape event itself and then run the create scrape event method. So let's go into a new notebook in here that I've got this setup event on that I can actually run this scrape itself, which I'll actually restart and clear all the outputs here, because I also want to do from products models. We're going to import that product scrape event, and then we'll call product scrape event objects and then dot, and we called it create scrape event, and this is going to be our data and our URL. Okay, so let's go ahead and run it now. Looks like our product scrape events come through, and I'll let that finish. Once it's done, I'll go ahead and do a query set just to see if we actually have any data that's coming through here, assuming I didn't make any errors creating out that model itself. Now, I'm not going to spend a lot of time refining this model at this point. The point of this is to really have a proof of concept working to where we can save the data into our database, and then we'll start to schedule it. There's a lot of things that you could do to continue to improve this. One of the things I would consider doing is having a serializer function, like using the Django Rust framework, for example, just to serialize this data to make sure that's working correctly. And once you use a serializer, you can parse it out into the different fields as you see fit, instead of doing stuff like this and like this, right? You could also use Pydantic for this as well, if you're familiar with that process. But now I went ahead and ran this. Looks like it did scrape. And if I go into my query set here, I should be able to see that event. Now, of course, if I were to just run it one more time, I may or may not get the correct values. So what I'm getting here is this unique constraint failed. So I actually made a major mistake on the scrape event here, and that is the asyn itself. I no longer want this to be unique, and I don't need it to be the DB index either. I'll go ahead and say null equals to true and blank equals to true in here. Just a minor change to it. So we'll go ahead and run python manage.py make migrations. You want to run your migrations every time you change your Django models, and then you run the migrate. And I don't know if it's going to work now, but there it goes. It actually did work, so we didn't have any issues. We might have had to restart the actual kernel itself. This is great. So now it's actually working. Let's go ahead and just see our products. Let's make sure that we only have one product. So product QS equals to product.objects.all. We've got multiple scrape events, or in theory, multiple scrape events. And then the product itself, the actual query set, we should only see one. Great. So everything worked as needed. We were able to enter a bunch of scrape events in here and only have one product come out. Now that we've got that, we want to actually put this into an actual function inside of Celery, a task itself, to run this whole thing instead of it being in a notebook. Now let's create a basic Celery task to do what we did in the notebook itself, which is essentially scraping a URL and then storing it as a scrape event itself. So inside of products here, I'm going to go ahead and create tasks.py. It needs to be named task.py for Celery, as you may recall. And then we're going to do from Celery, import the shared task itself. And we're going to define scrape product data, or rather, let's call it scrape product URL task. And it's going to just take in a URL. So inside of here, what are the things we need to do is open the URL and then scrape the URL and then save the scraped data. Simple, 3 things in here, which means we need to bring in our helpers once again. So those helpers are, well, 2 of the 3 things here. So I'll go ahead and bring them in. First off, the HTML and then the data. So the final one, as in saving the data itself, we actually need to think about how we're going to import this. So on one hand, we can do from.models, import the product itself, and then we can go ahead and run that, or rather product scrape event. We can actually run product scrape event.objects, then dot, and we called it create scrape event of the data and the URL itself. And overall, this is fine. This would work as long as we actually put this in as a shared task. But the problem with this, of course, is where does this URL come from? If it came from a notebook, this would definitely work. But if it's going to come from a product, let's say, for instance, we wanted to add the URL field right into the product model itself, then we've got a new issue. That's because of how we're importing this. So in other words, if I wanted to actually call the task, so from .tasks import, let's import the task itself. I want to import it here and then maybe call it in a future save method in here. Something like that, right? I want to call it in here with some things that just aren't in this model just yet. We've got an issue, and that is a circular import. We're importing it here, we're importing from models, and we're importing from tests. They're importing from each other. This causes a big problem, especially when it comes to models themselves. So we need to change this just a little bit. And what we do is from Django.apps, we import apps. And so what we can do with apps itself is we can declare the model from apps.getModel, and then you pass in the products, and we can just do products and the model name itself, which is this. What this does is import it for us without actually importing the class itself, and then that way I can actually run this when I need to at any given time, including inside of the model itself. So to illustrate this purpose, what I want to do then is I actually want to bring that URL back into the product model itself, this URL. Whatever the URL ends up being, I'll go ahead and update it in my defaults as well. So URL in here as URL. So overall, that URL changing doesn't matter that much in the grand scheme of things. It will matter in the sense of what ends up happening with parts of the URL, but that's not something I need to worry about right now. But rather, when this is being saved, how do we actually go through and run this scraping event itself? So let's go ahead and try that out. First off, what we do is we are going to save this with self and args and keyword args. And then we'll do the default save, which is just calling super on here, dot save, and then args and keyword args. Okay. And then we just are going to call this task, and we'll just say delay, and URL is, well, self.url. Using .delay, as you recall, we'll turn this into a Celery worker function here. I also want to make sure that I do have self.url in order for that to work correctly. And so this means that every time I save this model, it's going to go ahead and add a new task to actually run the scraping itself, which may or may not cause an infinite loop. So we may not want to do that. So I'm going to go ahead and add in one more thing, as in trigger scrape, and we'll do models and dot boolean field, default being false, and this should be scrape. And then I'll go ahead and add in another value for this as trigger scrape, once again being false. Basically then is we would change the ordering of this a little bit and say if self.url and self.pk, as in it's not a brand new instance here. Then we can say if self.triggerScrape and is not self.triggerScrape. Basically, if they're not the same, then we can come in here and do that. And then self.triggerScrape is false, and then self.triggerScrape is also false. There we go. So this right here is just a simple way to make sure that we can scrape it whenever we save it and with our own intention of doing so. Great, so with this in mind, I made a bunch of changes to the models. Let's go ahead and run python manage.py, make migrations, and then we'll do python manage.py migrate. Okay, great. And then the next part of this would be to test out the task itself. So let's go ahead and bring up Celery. And as you recall, we have it in our commands here to run it, which is this right here. We want to bring up Celery, make sure that that's running. If for some reason you don't have your Redis instance working, it's a good chance that maybe you don't have Docker up. So I want to make sure that Docker is running. And then I'm going to go ahead and minimize that. And then Docker compose up once again. And I'll go ahead and now run Celery. This time it should work. And we should see those new tasks in there. So with that new task in there, I'm going to go and look at my notebooks now. I want to duplicate this one. So we'll go ahead and do save notebook as, and this is now going to be 7. And we'll run our, let's say, trigger model or trigger scrape task. Okay. So now I'll go ahead and instead of importing the models, we'll import the tasks themselves. And we'll go ahead and do that with tasks. And I'll go ahead and grab the task itself, which is here. Okay, so we got that. And then the URL is fine. We want to leave that URL in. And I'll do product task delay of that URL. Run that. And I get, not defined. So let's make sure I run everything. Async result. Great. Let's go into our Celery. We see that it's running. We've got the print statement going through here. This will take a little bit of time because, as we've seen within our notebooks themselves, that always takes a little bit of time. We've got scraped content. While that's still running, I'm going to go ahead and bring these data points into my Django admin. So we'll do from.models import product and the product scrape event, and then I'll just register them with admin dot register and I'll just register them with admin.site.register product, and then we'll copy and paste that product scrape event. Okay, looks like this is still running, and I'll go ahead and make sure I have a super user in here. So python manage.py create super user. I'll just use whatever username and whatever password. And let's go ahead and run the server now. So Python manage.py, run server. Great. So now we're going to jump into the Django admin with that username and password. I use the same one all the time for development, which is why it's saved there. I see my products in here. There's one of my products. Great. I see that the URL is now in there because I ran that scrape event. If I look at the scrape events, I now have a few in here, and this is probably the most recent one. I could obviously just delete all of these and just run that same process again to see if it builds out another scrape event. So I'll go ahead and delay it, and let's delay it again. So it just ran 2 more times. And so eventually it's going to go ahead and run both of those things, which we could verify by going back into what is happening with our scrape events. We can see that it's doing it in 2 instances right now, and it's going to scrape them almost side by side. Now, I typically do not want these scraping events happening like this. I would rather have all of the products to be slowly scraped over time, right? I don't want them to run really, really quickly. And so that's something we'll do in just a little bit. But there's our scrape events. Looks like I actually ran it maybe 3 times, or maybe the fact that I called it a couple of times and it ended up doing it more than I wanted to. But the overall idea here is we are now seeing this data come through. Cool. So it actually might be going through on a natural, scrape event trigger. It might be actually running through over and over again. Probably something to do with this save here. That might not be actually accurate. Yeah, so we ran into that issue. This is a little bit of an issue. We'll go ahead and get rid of this. Now what I'll do is close out all of my Celery tasks. The reason being is so that this save method won't cause any trouble for me, because it is definitely continuously scraping in a short duration. That is absolutely not what I want to have happen in here. But overall, the idea being that we are scraping, we have the ability to do it on demand. We just need to turn it into where it's being scheduled and think just a little bit differently on how we want to do this. Now, in this case, I want to terminate all processes. So I'm going to hit Control-C twice in a row just to make sure that it cancels everything right away, because it's doing way too many scrape events up front. So let's go ahead and just get rid of this altogether. Now, I will say in the long run, if you were to want to build something like this out, you totally could. The main reason to show you this was the importing, how I actually have to do importing if I were to want to reference a model and a task in both places. And so that's why I wanted to show you that itself. So I'm going to go ahead and kill this terminal here to make sure that Celery is no longer running. And then we'll just go ahead and refresh in here. Yeah, I got a lot of different scrape events. But the cool thing is we see that it's working, and we should also be able to see that maybe the price is changing. It's probably not over that short duration. So we want to spread this out and start scheduling it, and scheduling it through the admin itself, as we see a bunch of periodic tasks, the ability to schedule them right in there, which is pretty cool. Now, part of the reason I wanted to show you this save method here was to show you how easy it is to accidentally do too much on your worker process, to actually trigger way too many tasks, because you can have some faulty logic inside of a condition, and then that causes that task to continuously run over and over and over again. Now, of course, I could actually improve this by saying that it is an trigger save that. Then basically, if it's not, or basically if it's not equal to that, these are now saying, hey, if this says true and this says false, then they're not equal, and we can run this going through. And we could solve this in many different ways. But the thing is, I actually don't want this method to happen. It is a nice thing to use sometimes. Every once in a while, you might want to trigger something right inside of the Django model itself. But in our case, we don't want to do that. So I'm going to go ahead and get rid of it altogether. And instead, what I'm going to do is change this to just simply being active. So the product itself is active now. And so I'm going to go ahead and update my models with Python manage.py, make migrations, and then we're not going to rename it. We're not going to rename anything. In fact, I want this to be true. And I'll also go ahead and add in help text being something like we, scrape daily or something like that. And now I'll go ahead and run those make migrations again. I made a minor change once again, and I'll go ahead and do Python manage.py, migrate again. Now, in my case, it says no migrations to apply, but yours probably created migrations because I did some tests off the video. Now, before we go down the rabbit hole of what I want to do with this active, I want to actually get rid of some of my old tasks. So inside of celery.py, I'm going to scroll down here and I'm going to get rid of all of these. I'll comment them out. Then I'll go ahead and jump into the Django admin. Let's go ahead and make sure that our actual Django project is running. So we'll go ahead and run that server here and jump into the admin. Then into periodic tasks. I got all of these tasks in here. I want to get rid of these. I can do the backend cleanup. That's something that's okay to run every day. But the other ones, the actual ones that we're running, we can go ahead and get rid of those altogether. And then we want to restart Celery itself, because we got rid of all of those default tasks that were running. At this point, those tasks are still in there, but they shouldn't be running on a regular basis. So the next part of this is going back into the admin, into task results, and then go by completed date to today, and just select all of the ones that are in there, and just delete everything from today. So you have no tasks. The main reason is so we can actually see that our tasks are working correctly, all inside of the Django admin. So at this point, we want to actually create a new task for doing all of the scraping of those products. So the reason I actually bring in a flag like this is so that this could be considered as to one of the things I want to scrape, maybe on a daily basis or however often I want to make it run. That will be up to us inside of the Django admin. So that means then inside of task.py, I'm going to go ahead and copy this task and paste it below here. This is now going to just be scrape products task. It's not going to have any arguments. We don't need any arguments in here. Next up, we want to get the product model itself. So we'll go ahead and get rid of the scrape event model. And that's pretty much what we're going to be doing. Next up, we'll grab our query set, which will be products.objects.all. Or what we could do is we could come in here and go based off of active. And that's kind of the point here, right? I can filter this down now to being active, being true. And then we can run through each object inside of here and really just grab the URL from that object and then run the same exact task and just pass in that URL. Now it's important to note that we are not passing the object itself. If you want to pass in the product object, you're really going to pass in the product ID and do some sort of lookup in the task itself. Or this needs to be JSON data that you're passing into a delay call. It cannot be an object inside of Python. It needs to be JSON so it can actually go into Redis and be moved around. The actual product object itself won't work, and you would see that if you did an error, or if you actually tried to see it and try to do it, it would actually run an error. So cool. Now we got this scheduled task or this shared task that we can run on a schedule at any time. Now, another thing to note is this query set, we can actually do things like values list and actually break out this data itself. We don't necessarily need to do the entire query set, but I'm going to leave it in as just a query set and just know that this could be improved quite a bit, including whether or not the URL is in there. So one of the things with this scrape task, I'll also make sure that if the URL is none, then we'll return none, and if the URL is equal to maybe an empty string, we'll also go ahead and return back from that task itself. Those are just the main things that I want to change. So with this in mind, notice that Celery is not running all of those other tasks anymore, so we can feel good about that. I'm going to go ahead and close it down and then restart it with that new actual task that we got in there. And then I also want to make sure that my server is still running. Sure enough, it is. I'm going to go into the Django admin now, and we're going to create a brand new scheduled task by going into periodic tasks, clicking on this, going into our task itself. Whatever the task name is, go ahead and grab that. Make sure that you do not now change that task name. So once you put it into the database, you want to make sure that it doesn't change in the future. Otherwise, you'll have to delete it. Now, in our case, the interval schedule, I'm going to do it every 30 seconds just to make sure that it's working. But realistically, I might want to do it every day or something like that. You can do it in a CRUD tab. You can do it all sorts of scheduling. You could also do it as a one-off task, so it just runs that one single time, which is definitely useful sometimes. Next up for the name for this is I'm going to call this Scrape Products Daily, and we'll just go ahead and save this. As soon as I save it and I go into the Celery worker process, I should see that the database scheduler schedule changed. Now, if you don't see that, there's a really good chance that you're not running the beat server. So inside of commands here, you're not running this right here, or somewhere else your configuration is done incorrectly. But with this scheduler changed, every 30 seconds now, it should actually run that task itself, assuming we made that task correctly. So what I want to do then is I want to just verify that that task is working by going into the notebook itself and just bring it in like that. I don't need the old one, but I'll just go ahead and run that scrape test itself. So in my case, I get this problem with this no such column. Yours won't have that. I'm going to fix it real quick. Okay, so I went ahead and did it. I went ahead and deleted my database and then restarted basically everything we just talked about. And in my case, I actually didn't scrape anything yet, mostly because I don't actually have any products in my database. So I'll go ahead and scrape it once with this URL. That should scrape all of the products. And then I'm going to go ahead and run this daily task, which should also be able to scrape these daily as well. So going back in my admin, if I go into my products here, I should have a single product in here soon at the point once it's actually finished. So there's that product finally. I've got it being active, and it'll go ahead and run that on a regular basis. And we can verify this by looking in our task results coming through in here. Eventually, we'll see a bunch of different task results coming through and making sure that's working. So that's actually allowing us to run this at any time. Now, the other cool thing about this is if we ever need to just run it right now, like I want to scrape all those products right now, you could just do this one-off task, hit save, it's going to run all of them. Of course, it disables the old one, so you could always make it a new one, or you could just do what I just did, which was re-enable it and then turn off that one-off task, and then it's back to doing it every 30 seconds, which is maybe what you want to do, maybe not. But at this point, it's now going to be running through that process for the individual product. So now if you ever wanted to run an actual individual product, if you wanted to bring a new one in, what you could do then is you could always go to another URL. I'm going to go to that Xbox URL that I have stored here. I'm going to go ahead and grab this one, and I'm going to go ahead and open it up, and I'll just go ahead and see, okay, cool, I'm in Xbox. I'm going to grab this URL here. We're going to go ahead and create another new product. The ASIN has to be in there. I'll go ahead and add the URL in. So I need to find the Amazon standard identification number, and we'll scroll down, look for it. It's in the product information. There it is. I'll go ahead and save that. Active, we'll hit save. Hopefully now what we'll end up seeing is this one being scraped in just a minute, and a lot of the data also will be updated as well. So I'm going to leave this for just a moment just to verify that the whole process is working and it's working correctly. One of the other ways I can verify this is just by going into the worker itself. I can see that, hey, what do you know? It's actually navigating to that product as well as the other one. So this is a really nice thing about the worker process too, is since we are delaying the tasks right here, that means that it's going to go on another worker process as well. So if we had a bunch of Celery instances running, it would be able to handle this and scale really, really well. Now, if for some reason you didn't want to do that and you wanted them to go in actual order, you could just get rid of that delay. This will still be done inside of Celery, but it won't be redistributing the URL tasks themselves. And so that's another cool thing about it as well. So now if I refresh in this product, there's all that product data. I can see that I now have a bunch of different scrape events in here. It might be the current product data, it might not be, but it is now definitely grabbing all of that data as we see fit. And it's going to go ahead and track that current price over time. Now from here, we could do all sorts of cool things with it, including like doing data analysis on here or finding the, mapping when the price drops and all that. That's outside the context of this one, but we now have a way to scrape this data from Amazon, do it over time, and do it on our own schedule, thanks to all of the tools involved. Hey, thanks so much for watching. Hopefully you got a lot out of this. Now, if you want to take this a little bit further and actually add in AI to the mix, and that is self-hosted AI, you don't have to pay for it, you just use it locally. Check out this free course right here on Udemy. I built that course with Bright Data as well as this video, so it's going to be a lot of the same sort of themes, but the general idea is you'll be able to use AI in the mix of the things that you're doing here. And the challenge I would leave you on is how do you actually mix AI into what we just did? How do you bring it into the entire ecosystem of web scraping, because now you can scrape anything thanks to Bright Data's excellent tool. So if you do have any questions, or you have any concerns or ideas for future things, please let me know in the comments. I definitely want to build more stuff for you so you can scrape better or just build better automations. Thanks again for watching. My name's Justin. Look forward to seeing you next time.